Okay, so now let's look at example 3. So this is a region lying between two intersecting graphs again. So the sine and cosine curves intersect infinitely many times, bounded regions of equal areas. So they have the same kind of thing that repeats over and over and over again. I'll draw that out. So it says find the area of one of these regions. Oh, excuse me. So if I had a graph of sine and cosine, so we're gonna say we'll make cosine, or well, whatever. We'll make sine green, and we'll make cosine blue. So, and I'm just gonna draw this very basically. So sine starts at 0 and kind of curves around like this. Cosine starts at 1 and then cycles around. Oops. So sort of a kind of an interesting, obviously pretty terrible looking graph, but we can see that each of these little areas should be the same. Let me draw this a little bit better. So like this area is going to equal that area, which equals that area, which equals that area, and so on, in between the intersections. So despite my poor graph, it does not matter. So we just need to pick one particular section to do. I like using positive numbers, so let's do this graph here. Okay, so we need to figure out where do these points actually intersect. We do not know. So we need this point and this point. So we need to say, okay, well, when does sine equal cosine? When do they have the same value? Well, for these, this part right here, this is the first place that they are the same. And so we're going to say, okay, that's pi over 4. That's the first place. The second place is when they're both negative. They are negative down at 5 pi over 4. So, and that's based off our unit circle again. So that gives us what our bounds are going to be. So we can actually set up our area here. So our area is going to be the definite integral, and this is going to be from pi over 4 to 5 pi over 4 of sine, which in this case sine is on top, so we get sine of x minus the cosine of x. And that's grouped together based off of the with respect to x. So now that we have this set up, we treat it again just like a regular integral, and so we're going to go ahead and integrate. Well, sine comes from negative cosine, so we get negative cosine of x, and the integral of negative cosine is going to be negative sine of x, and this goes from 5 pi over 4, from pi over 4 to 5 pi over 4. So now we need to go and integrate, or now that we've integrated, we have to go forward and plug stuff in. So we start off, we plug in 5 pi over 4. So we're going to have negative cosine of 5 pi over 4 minus the sine of 5 pi over 4. We subtract away, plugging in pi over 4, which is negative cosine of pi over 4 minus the sine of pi over 4. So now we can evaluate this. So the cosine of 5 pi over 4 is negative square root of 2 over 2. So a negative square root of 2 over 2 makes a positive square root of 2 over 2. Sine is the same, so we subtract away a negative, which means we're actually adding the square root of 2 over 2. Now, the cosine of 5 pi over 4, the cosine of pi over 4 is the square root of 2 over 2. So this is negative the cosine of pi over 4, which is square root of 2 over 2, Sine is also the same, so we do minus the positive square root of 2 over 2. And then we go and continue to solve now. So the square root of 2 over 2 plus the square root of 2 over 2, that makes, 2 square root of 2 over 2. We subtract away negative 2 square root of 2 over 2, which this is 2 square root of 2 over 2, which again, that's the same thing as the square root of 2. We can think of that as canceled. We then add, because we have a negative times a negative, we add the square root of 2. And so your final answer is going to be 2 times the square root of 2. That is the area between sine and cosine that occurs every single place. So all of those little areas that we talked about earlier are 2 times the square root of 2.